Hello and I welcome you all again. So in today's lecture we are going to discuss about the bar bending of a slab. In bar bending of slab we will start from the schedule of slab, that is the part of any of the shop drawing in which it is clearly mentioned that what kind of steel bar we are going to use, its diameter, distances, and also the slab thicknesses. So we will start study it by one. Schedule of slab, and the name of the slab is divided, but we have done in the case of footing like f1, f2 and so on. In the slab s1, s2, s3, slab thickness is mentioned 150, 150 and 180. Keep this into your mind because it is important thing to know. Then at mid span and supports. Okay, there are two kind of bars using in the slab, that is bottom bars and second is the top bar. So there is always two direction. One is the shorter span. The shorter span is considered the which is main bars, and there is a long bar that is considered at the distribution bar. Mostly the distribution bar center to center distance is more than the shorter span because the main weight is basically sustained by the shorter bars. And same the case in the top bars and bottom bars. And there are also some of the extra steel bars we are using basically on the support, near the support, and also at the corner edges. So we will see this on the drawing when we study the plan. So this is basically the schedule of slab that is always present by the designer, and it is part of the drawing. The next thing, if we see that this is the whole building which we have started from the beginning, and as you can see that we already draw all the bars according to the requirement. In my case, what I have done, we will start from the bar 1. As you can see that this bar 1 is 12 number dia bar, 150 mm center to center distance. Numbers we will calculate based on our cross section and length and all that. But before I go deep into it, so I will take you to a section that what is this 0.3 L and how this bar is only this much length, why this bar has full length, and you can see it is coming over each other. So I will take you to the section so that you can understand what is basically this. Okay, so this is the typical section of the slab. As you can see, the column is running from the slab, so it's mean that there is a column going down and there is a column going up, and this is called the center support, and this is also called the center support, and this it's mean that this is a continue running towards the next support. Okay, as you can see that there is a top bar. Okay, this top bar, the length is from column or beam or any structure, it is 0.31. Okay, so we will consider this full length from one spot to another spot, from this position to this position, and then we will multiply it by 0.3. There will be a length will become, so this length will consider as this bar. Okay, this 0.3 L. Okay, in this case, what is this 0.3 L? This is the total length 4.96, because this is coming from this to this one. Okay, but make sure this is continue from this area. Okay, so from this position to this position it must be 0.31 plus the thickness of this column. You can find it according to the dimension. So this is the first bar which we are talking about, so we will keep everywhere where this type of condition is. So we distribute this bar as a S3. Okay, so we are terminating up to here. So in this case this is coming like this to the outer direction. this is we again use that bar, this is again we use this bar, and here we use this bar again. Okay, so wherever there is a outer edge, we need to use this detail, especially this detail. Then if you see go in this direction, you will see this this kind of bar is not used in this particular portion, because this is center portion. To center portion we need to follow this particular point. Okay, here you can see there is no hook, there is no bend, but it is just simply placed a bar over here. So in this case 0.3 L1 and 0.3 L2. L1 means length of left side and L2 mean length of right side. This is 0.3 L2, 0.31 L1. So this you need to consider as for the left side. You always need the left side of the dimension. For right side you will follow the right side of the dimension. Okay, and this is everywhere. So basically you have to focus on two. One is the corner support, one is the center support. For corner support you need to place an additional bar, but for the bottom bar, as you can see that this is going through, so there is no space. The second point is the overlap. This area is called the lap. Okay, and the designer already tell us that this lap will be 50D. 50D means 50 is the standard, D means the diameter. Diameter of what? This tail bar. This tail bar is, if this tail bar is 12 mm, so 12 into 50 mm, so this length will be defined as this. Means this lap will be go on 50D distance. Okay, so this also I consider it. So we will I hope you will understand all the points. Then there are stirrups that is coming for the beam. We will see this one by one, that what we have done. Okay, in the case of one, as you can see, number 12, 150 mm center to center, number 38. How we know that? We follow this particular length and we just link this one. As you can see, this is 5.56, this is 5.56. So means from here to here, this will span up to this level. Okay, in the second, number 2 is this bigger length of bar. So what we will do, we will double click again over here, so you can see 5.56 meter in this case also, because we will place it in this direction. So this and this we need the same length. Okay, now if we talk about this one, that is perpendicular to it, basically double click over here and 4.96, this time we will use this length. Okay, so this is basic concept behind it. Then if you see over here, this is a again the overlap. This overlap I also carefully measured first, then I placed over here, because the length of the bar is exceeding, so I put over here the over the lap. Okay, you cannot put lap in the center, because if you put, it will be weaker. So this is basically coming from the design drawing, so you don't need to be too much headache. But being a QS, being a estimator, you should know that what is the technique. It is 50D, 48D, 60D. So you have to place over there, because when you are working with auto rebar. So this is S3 type. Okay, then we move S1. We are using same technique for everywhere. As you can see, this is the central portion, center support. That's why we follow this design. Again the same thing, and here we did the same again. As you can see, we are using the slab. Wherever it required overlap, we are using the desired length. And for the S2, as you can see, we are using the same method. Okay, So this is basically the design we need to follow. What is the three important point you need to follow? First is the bottom slab, bottom bars. This bottom bars is this consider as the, for shorter span you will consider this as a main bar, and the upper bar is considered as the distribution bar. Then what is the top bar? And this is the top extra bar. You just need to know this length so that it is easy for you to understand how much length it will be extended. Then the lap 50D. So these are the points which you need to know. Then you will place all these detail. This reflection is placed over here, and then you will copy this markings. Okay, this four is same, like this bar, this bar, this bar, it is all is going same. So what we will do, we will simply use one mark by copy this one from here. Like for example, if I copy this one here, it is present, so I will copy over here. So it means the detail for this bar is same as this bar. Okay, so this you can do. Like for example, here if you see one, if the length is the same, what you will do, you will use one again. See, this is also one, and in this case if it is different, so we will use it different one. Okay, and if you see here 17, this one, this length, this is 14. So if it is changing because of this span, so the mark is different. If the mark is not different, if it is same, like for example, I need to check this one whether it is similar to this one or no. Okay, so how we know? First of all, I need to know this this dimension 5.56 here, and if I see here it is 5.56, it's mean it is same. So we can just copy this from here. Okay, so this automatically building over estimate without making any mathematical calculations. Now this is the last step to draw the table, this bending schedule. Just specify intersection point, and as you can see that this is already been drawn now from 1 to 20. Okay, so this is 7,051 kg, the weight we are going to use in the slab. So it is a bigger area, and a lot of steel is using in the slab. So this is the steel we are going to use over here. Okay, do not be overburden yourself when you see any detail. Okay, you just focus on three important things: what is the bottom bar, what is the distribution bar, what is the main bar, what is top extra bar. Okay, once you know, then you will move to this overlap and what is the bend. Once you know this, just take a time, think on the drawing, understand every step of the drawing, then you will start estimating it. Okay, like we will check here mark 8, and this is it. Okay, so this bar, this top bar is considered as this 8, where you can see that the length is, number is 60 and length is 4.2. Okay, this 4.2 and 60 is the numbers. So this is our estimate. This is all for the slab. We will meet in the next class. Thank you.